Algebra 1, Lesson 33, we are looking at independent and dependent probability. So, big idea is being able to identify independent and dependent probability. And we define those by saying independent events is the outcome if one does not affect the other probability. Dependent, we're saying that one event does affect the probability of the other. And odds, we have a ratio of favorable outcomes to unfavorable outcomes. So let's look at some different situations. And this is a good one to kind of get your mind around independent and dependent. So if you think about all of the students in your class and each popsicle stick has a name on them, well, you would say maybe there's 25 students in the class and your name is on one of them. And if we pick one of those popsicle sticks and say the name, we put it back. So the first time, we would have a 1/25th chance of getting your name. Well, we read it and we put it back in, and we once again have a 1/25th chance of pulling your name. It goes back in the cup. Whereas if we were to pull out a name, okay, that's a 1/25th chance of it being your name, but keep the name out of the cup, now I have 1/24th chance of being picked. Okay, so keeping one of those popsicle sticks means we have dependent probability, because the probabilities change. Now, here are some key words, key terms that you can use to remember the difference. Well, independent probability is we pick something, then return it, which makes the denominator stay the same. And the item has the same probability of being picked each time, just like we said in our popsicle stick example. We have 1/25th in the first time and 1/25th in the second. Key words for this are you can replace it, return it, put it back. And we can do multiple picks, that's fine, but we have to pick one at a time. Now, on the other hand, dependent probability, we're picking something and keeping it. So each time we pick something, the denominator decreases because we have one less thing to pick from each time. And the item has a better probability of being picked. Like we said, you have a 1/25th chance of getting picked the first time, whereas once one of the names has been called, you have a 1/24th chance, which is better. Some key words are you keep it, you don't return it, and once again, we can have multiple picks, but only as long as we pick one at a time. So here are some good examples of independent and dependent. So rolling a number cube and flipping a coin twice, replacing a marble from a bag and then choosing another, picking a flower from a bunch of flowers and then choosing another flower from a different bunch, and guessing on 2 multiple choice questions. Whereas dependent, choosing a marble and keeping it and then choosing another, or taking a coin from a jar and keeping it and picking another coin. So let's look at this example. You toss a coin and then roll a number cube. So find the probability of getting heads and then rolling a 6. So first question, is this dependent probability or independent probability? And you would say, well, because we aren't affecting probability, we have independent probability. And we just need to find the probability of each part so that we can multiply them together at the end. So we'd say the probability of getting heads is 1/2. Probability of getting a 6 is 1/6. So we would multiply those two together and get 1/12. So that's just our simple independent probability. And we can do that again with this one. We have drawing 2 blue marbles and replacing after the first marble is picked, and drawing a red marble, then getting a blue marble. Both of these are independent probability. So we say, all right, there are 8 marbles in the bag, and the probability of getting a blue on the first draw is 3 out of 8. Well, we put the marble back in, so we still, for the second blue marble, we still have a probability of 3 out of 8, so we have 9 out of 64. Whereas on the second one, We want a red marble, which is 5 out of 8. We replace it, so getting a blue marble is still that 3 out of 8. So we get a probability of 15/64. Those are two more examples of our independent probability. Now let's look at these side by side, looking at independent then dependent. So we have all of these candies in a jar: 6 blue, 3 red, 5 green, and 2 yellow. Well, that means that there are 16 total. And for the first one, I am going to pick a candy, put it back, and then pick another. And I want a green and then a blue. So the probability of getting the green is 5. I'll write it up here. 5 out of 16. And then we multiply by the probability of getting the blue, which is 6 out of 16. The only simplifying we can do is here we have 3 and 8, so we get 15 out of 128. That would be the probability independent probability. Whereas if we were to pick a candy and eat it, and then pick another candy, well, we would say the probability of getting 2 greens would be, well, the first green I have 5 out of 16. But once I eat it, I only have 15 candies left, and there are only 4 of them that are green now. So I can simplify here a couple times: 4 and 16, 5 and 15, and so I get a 1/12 chance of getting a green and then another green without replacement. A couple more examples. A card is drawn from the deck of 8 cards with letters A through H. The card is replaced and a second card is drawn. So what's the probability of getting a B and getting an F? Well, for the first one, it's independent probability, so our denominator is going to stay the same. We're going to multiply, and then I say, well, the probability of getting a B is 1/8. Probability of getting an F is 1/8. So I should see a solution of 1/64 here. But the second one, we say, well, the probability, if we don't replace it, the probability of getting a B is still 1/8, but once we go to pull an F card, I only have 7 cards left, one of them being an F, so I should see a probability of 1/56. It's a better chance when we don't replace it. Okay. So, a jar contains 6 blue, 3 red, 5 green, and 2 yellow candies. We're just going to try a couple of these. So the probability of 2 red candies if replaced, okay, so we would have 3 out of, let's see, we have how many? 16. So 3 out of 16 times another 3 out of 16 since we replace it. And we would multiply that out, so we would get, what, 9 out of 256. Let's see. Number 5, probability of a red then a green. So we would say the red would be 3 out of 16, and then we multiply it by the green, which is 5 out of 15. And we can simplify. And so we have a 1/16 chance of getting a red then a green with when it's not replaced. One more. How about the 3 greens if not replaced? So we would say, all right, my first is 5 out of 16, but then I eat one and I only have 15 left and 4 of them are green. Then I have 14 left and 3 of them are green. Okay, so we can simplify and we say, all right, the 5 and the 15, the 4 and the 16, the 3 and the 3. So we get 1 over, let's see, 56, I believe. Okay, so those are our independent and dependent probabilities. Now, the last part of this is about odds. And really, this is just a ratio. Number of successes to number of failures. Or you could say number of favorable outcomes to number of unfavorable outcomes. So we assume that all outcomes are equally likely, and if we have m favorable and n unfavorable, well, then the odds are m to n, and the odds against are n to m. Okay, let's try a couple of these. What are the odds of getting a 1 on a number cube? Well, we would say I have one that is favorable, one side of the die that is favorable, and 5 that are unfavorable. Now remember, odds are not asking for a probability. It's a ratio. So the odds of getting a 4 is 1 to 5. Odds of getting a 3 is 1 to 5. And then for the odds of getting an even number, well, we would say we have 3 even numbers to 3 odd numbers. Well, that's just a ratio of 1 to 1. Remember, we want to simplify down as much as possible. Okay, so with this spinner, the odds of getting an orange are 1 to 3. The odds of getting not blue, well, I don't want blue, so that means 3 of them are good, but 1 of them is bad. Odds of getting a green is 1 to 3. And red or green, that means 2 of them are good, 2 of them are bad, so I have a 1 to 1 ratio. The odds are 1 to 1. And this is an example that you can work through, and I'll just pick a couple here. But if we have bowled 250 frames, what is the probability of knocking down 4 pins and the odds of the event? Well, knocking down 4 pins, that means that I have 23 out of 250 probability, but that is an odds of 23 to 227. Or the probability of getting a gutter ball, well, that's 9 out of 250, and that would be an odds of 9 to 241, right? 9 of them make me successful getting a gutter ball, 240 of them were not successful getting a gutter ball. Knocking down 8 or 9 pins, well, that means that we're looking at both of these two numbers. That means that we have 39 of them out of 250, that's the probability. And we could say my odds are 39 to 211. Okay, and of course we want to reduce as much as we can with any of them if it is possible. Well, I hope this is helpful for your homework and for studying.